All right, you ready? You ready? All right, here we go. So yesterday, you guys are doing a really nice job. We had a situation. Now, each individual group had their own situation. I will just diagram a situation up here where you had something like a car coming in here. It's going to hit a heavier car. That's the before side. And the after side, let's say mine hit and stick together. Is that cool? You all visualize that? Now, in mine, I'm going to color my cars green and blue. Here's my green. Here's my blue. Is that cool? And then I wanted you to draw bar charts for these. Now, in this situation, there's only kinetic energy. No big whoop. And we see that the green one has kinetic energy coming in. And then afterward, what do you notice? They're both moving now, correct? So do they both have some kinetic energy? They do. Okay. But because they collided, we lost some also. And what is in our system? What are we considering? We'll call this card B. All right, how's that look? Is that cool? So this is what you guys were working on yesterday. We're going to continue to work on that today. But I wanted you to do something else yesterday. All right, and we're going to do that today also. You ready? All right, is I want you to calculate something. Now, the reason for it will be obvious later, but I want you to understand it now. Is you're going to do an M delta V for each object. Okay? M delta V for each object. So the delta is this triangle. It's from the Greek alphabet, like alpha, beta, gamma, delta, right? You've heard of the Greek alphabet before, yes? This triangle is delta. What does it mean in the science context? What does the delta mean?
Changes.
It's the change, right? And how do you calculate the change? You do
Initial.
final minus initial. Okay? You do final minus initial. That's how you always calculate change. Now, these are velocities, not speeds, so you have to know direction. So if your object is moving to the left, it's going to have a negative velocity. That's important. All right? So you guys, then you just calculate it. So do M delta V for car A. Also do M delta V for car B. And we're going to try to figure out how does the M delta V for car A compare with the M delta V for car B? How does that sound? Good? Does this sound doable? All right. Yeah, that makes some sense to me. So M delta V for car A, M delta V for car B. Sorry about that. Do some color coding here so that we can see these things. It's gonna help us later. Just kind of say like, oh, this is the green car. This is the M delta V for the green car. Cool. This is it for the blue. This is the kinetic energy for the green. The kinetic energy for green and blue. Does that sound good? All right. So now, that's what I want you to do. So if you have gotten through some of that, or most of that, or all of that, so go grab your whiteboards from the left side. take them to your stations. Let's finish this bad boy up real quick, and then we'll move on with part B of this.